In this example, we're asked several questions pertaining to the set of data given here. And for this particular video, I want to try to use StatCrunch as much as possible. So for the very first part, when we're asked to draw the scatter diagram, let's open up this data in StatCrunch. We will then go to Graph, Scatter Plot. We'll make sure that we select X for the X variable and Y for the Y variable and Compute. And this gives us an idea of what that scatter plot should look like. Just make sure that you pay attention to the scale in case you have to select a better option over one that looks very similar to this. Looks to me like this would be our best option. For this next part, we're asked to write an equation of a line containing just two of these points that are listed here in our table. So for this, I'm going to turn to by hand techniques since StatCrunch is more about the statistics part and not this algebra type of question. So I've just come over here to another screen so I can kind of step this out piece by piece. One of the first things that we want to do is find the slope between the two given points. The next thing we're going to do is use the point slope form for an equation of a line to write that equation. And then this last part just really depends on if my math lab is asking for it in a certain way. Often it does. It asks for you to solve the equation for y. So back up to the top here, we first want to find the slope between the 2 points. I've already written here the equation or formula, we could say, for slope whenever we have 2 points. So let's subtract the y values and then divide by the difference, or subtracting here, the x values. So let's substitute in those values. And calculate. So we find those two differences. Then last thing we do is divide, and we should get that a slope between these 2 points is -2. Next, we're going to plug in some information into this formula for an equation of a line given the slope and one of the points. So let's substitute some values that we know here. I'm going to use this second point. So the y value in that second point is 99. The slope we just calculated to be -2. And the x value of that point is 18. At this stage, technically this is an equation of a line, but if I go back to look at my math lab, it wants me to solve this for y. So I'm just going to do some algebra by distributing the -2. And I get this. And then I'm going to add the 99 to both sides to get the following. So at this stage now, my equation for the line that goes through the 2 given points is y equals -2x plus 135. Notice that it just asks for the parameters here, just the slope and the y-intercept. They've already got kind of the structure of that equation already set up. In part C, we're asked to graph that line on top of the scatter diagram. So here's where I really want to pay attention to the different graphs and their scales. Looking at these, I see 3 of these that kind of have the same shape of those scatter plots that we graphed earlier in part A. But this line is supposed to go through the points 10, 115, and 1899. And the best graph I see here is this one in part A. If I just really want to analyze it a little bit further, I can use this pop-out window just to get a better view of that graph, so I'm sure about what I'm selecting. All right, so now in part D, when we're asked to find the least squares regression line, we're going to go back to StatCrunch and use its statistical capabilities in order to complete this part. So I'm going to go back, open up my data in StatCrunch. I'll go to Stat, Regression, Simple Linear, the x variable was x, the y variable was y, and compute. I have a lot of information here, but what I really need is located near the top. And notice independent and dependent variables are what I told it to be. Also notice that StatCrunch lists the y-intercept first and then adds the linear term, the one that has the slope times the independent variable. So I just need to pay attention to that as I'm typing these into my math lab, that I'm picking up the right either coefficient or constant that I need. And you see here rounded to 2 decimal places how that looks in my math lab in this slope-intercept form for an equation of a line. For part E, we're asked to graph the least squares regression line on top of the scatter diagram. So for this, I'm going to go back and grab my results, the ones that I just had in StatCrunch. If I click this right arrow, I see that this is actually only one of 2 results that it gives me. On the second page is where you can see the scatter diagram and the linear regression. So I just want to make sure I'm picking the best choice that match my scale and the look of the graph. You may even want to kind of condense it down just a little bit so it looks a little bit closer to the shape that we have here in our choices. And after I've looked at those choices, I'm thinking that choice A is the best choice that matches what I had in StatCrunch. For part F, I'm going to try to rely on StatCrunch as much as I can, so I'm not having to create a chart and calculate this sum of the squared residuals like by hand. But just know that you can do by hand techniques because this one is not a huge chart, but I do want to show you some features that StatCrunch has in it. You may choose to use that. Okay, so because we're referring back to that line that's found in part B to get this sum of the squared residuals, I'm going to go back up to this line here, the one from, oh, not that one, this one here, the one found from part B. Okay, so let's keep that one in mind as we are trying to calculate these residuals. What residuals are is the difference between what actually happened according to the data and what the line predicts should happen according to those Y value outputs that you would get if you input these particular X values. Okay, so to do this, I'm going to go to data. Oh, let me back up for just a second. Notice that I'm hovered here on top of the first cell in the third column. Now I'm going to go to data and I'm going to select compute and expression. And I'm going to start to build this expression that will calculate those outputs that this line says should happen. Remember, this is the prediction of what should happen. So I can probably just type this one in exactly like I see it, actually. So let's do -2 times, now notice I'm using the asterisk here for times, x plus 135. We'll compute that. And it has added this value to this third column here. Okay, it has given it this name as well because I didn't give it a name, and I think that's okay for right now. We'll just leave it like that. Okay, so for what I want to do now is in this fourth column, I'm going to build an expression that calculates the residuals. Residuals are what actually happened in the data minus what was predicted to happen on the line. So what this next expression is going to do is subtract each of these. Okay, so let's go to data and compute expression. This time I'm going to choose to build my expression. So what actually happened was in the Y column, it was labeled Y. You can either select it and add it or just double click it. And then I'm going to subtract what the line said should happen or predicted to happen. I'll double click that and click OK, and it's build that expression for me. This time I am going to label it as residuals and compute. Let's move that out of the way. And here are the residuals for the line that we found in part B. What we're asked for is the sum of the squared residuals. So I'm going to just take this one step further and I'm going to square the residuals and then I'll add up that column. So again, I'm just trying to do as much as I can here in StatCrunch. You're probably seeing some ways already, thinking, well, I should just do that by hand, and that's probably just as good. So I'm going to go build an expression that is the residuals, and here's that caret key, like as if I'm raising it to a power, so I'm going to square that. I'm going to say this is residuals squared and compute that. So here are the residuals squared. The last thing I want to do is add these up. Actually, now that I'm looking at that, that's only 3 values really I'm adding up. 16 plus 25 plus 81. And so what I get is the sum of the residuals squared, according to the line that we found in part B, is 122. Okay, so next we're going to compute the sum of the squared residuals for the least squares regression line that we found in part D. This one is much simpler inside StatCrunch because it was built for these types of things. So actually, I think what I'm going to do is just close out the one I already had, like the StatCrunch screen I already had, and just open up a new window in StatCrunch here. So I've just opened up a new StatCrunch screen with the same data. I'm going to go to Stat, Regression, Simple Linear, and I'm going to run this regression again. So let's select X, Y for those corresponding variables there and compute. Remember we had this large printout of information, and actually one of these is the sum of the squared residuals. What StatCrunch calls this is the error, that's residuals, and the sum of the squares is what we're looking for, and that would be this particular value here. It says to round to the nearest integer as needed, so we'll say that is 36. This last piece is just a comparison of the 2 types of lines that we just found. The one that we found by picking 2 individual points and coming up with an equation of a line by hand in part B, and the one that we found using StatCrunch, the least squares regression line that we found in part D. So the sum of the squared residuals that we found for the line in part B, that's this one, the 122, is greater than the sum of the squared residuals that the least squares regression line had. That was this 36 here. And that should always be the case because the least squares regression line does just that. It minimizes the square of the residuals. Since the sum of the squared residuals provides a measure of variation in the response variable that is not explained by the model, that means that the line found in part D is the better fit.